So today we were talking about this. All of you remember strong form of induction. We were talking about strong form of induction. So what are the main steps of a strong form of induction? Can you see the screen?
Yes, sir.
Okay,
Yes, sir.
so can you see the strong form of induction steps?
Yes.
Okay, so uh, these are the main steps. What is a strong form of induction? So try to prove statement for n is equal to 1. Then assume that statement is true for all the natural numbers from 1 to k. And then verify or prove for n is equal to k plus 1. Right. So these are the steps. So the difference between strong form and weak form is in weak form we assume that statement is true for k, and from that we prove for k plus 1, but here we are assuming that it is true for all numbers up to k, and then we are trying to prove for next k plus 1. So let us see example so that you can understand it in better way. So where the example where we need strong form, weak form is not easy in that case. Okay, so keep your mic off. Keep your mic off. You should keep your mic off. You should take care of it. Otherwise, it creates lots of disturbance to others, right? Okay, so let us see the example. Let x1 is equal to 1, x2 is equal to 2, x3 is equal to 3. So for n greater equal 4 and natural numbers n, we define xn is equal to xn minus 1 plus xn minus 2 plus xn minus 3. So now prove that. Prove that xn is less than 2 raised to n for all natural numbers. So this is our claim. Now you understand how the numbers xn's are defined, right? Can you understand the numbers xn how defined? So x1 is 1, x2 is equal to 2, x3 is equal to 3. In this way we define. Now what is the x4 from this? For n greater equal 4, the value of xn is obtained from xn minus 1, xn minus 2 and xn minus 3. So x4 is x3 plus x2 plus x1. So therefore what is x4? x3 is 3, x2 is 2, x1 is 1, so it is 6.
It's
Right. Similarly, can you find x5? Right. Certainly you can find x5. So what is x5? Here n is equal
X4.
to x4 plus,
X4 plus X3 plus X2.
very good. So
Plus
what 6 plus 3 plus 2, that is 11. And in this way you can calculate. So consecutively you can calculate all the xn's, and you can calculate x5, x6, x7. You can calculate x6, x7, x8, x9 and so on, and you can calculate xn for all natural numbers, right? So when you are not talking with me, keep your mic off. Remember this always. Okay, so to prove this, this we want to prove for all natural numbers, so means we should use induction, right? And of course weak form is not going to helpful in this case. That means it will be tedious, so we'll use strong induction. So So we shall use strong form of induction. So strong form of induction. So what is the step 1? Right. So base step or base case. Since our aim is to prove for all natural numbers, so base case is n is equal to 1 because we want to prove it for all natural numbers. So we start from 1. So n is equal to 1. So if n is equal to 1, what is x1? What is x1? x1 is 1 and certainly it is less than, if n is equal to 1, xn is x1 and x1 is 1. 1 is less than 2 raised to 1, that is 2 raised to n. This is clearly true. Right, therefore the statement is true for n is equal to 1. So no doubt it is clear, the statement holds for n is equal to 1. Now the induction hypothesis. So since we are using strong induction, so what should be induction hypothesis in this case? So assume that the statement is true for n is equal to 1, 2, 3, k, up to k, right? We are assuming it is true for all numbers up to k. And what is k? Some k greater equal 1, whatever you can choose, k is equal to 10 or 100, doesn't matter. But at this instant we are fixing our k, right? At this instant we are fixing our k, and we are fixing our k, and we are assuming the statement is true for all up to k. Fine. That is, what does it mean? We are assuming statement is true for 1, 2, 3 up to k, means that is x1, please keep your mic off. X1 is less than 2 raised to 1, x2 is less than 2 raised to 2, x3 is less than 2 raised to 3, and so on up to k, xk is less than 2 raised to k. This is our assumption. Remember this. Fine. So certainly for k minus 1 also we are assuming the result or statement is true, right? So the third step. So inductive step. So what is our claim in this step? So prove that, to prove that the statement is true for n is equal to k plus 1. So we want to prove for next value of n, that is k plus 1. So that is, what is our aim? That is, we want to prove. So we want to prove that xk plus 1 is less than 2 raised to k plus 1. This is our aim. This we want, not prove, right? We want, this we expect. So, okay, so how to achieve our goal? Let us start with xk. So consider sum of previous 3 numbers, right? So what should be xk plus 1 now? K plus 1 is the sum of previous ones, right? So
xk plus
right, xk plus
xk minus 1 plus xk minus 2.
very good. Now, but by induction hypothesis, if I replace xk by 2 raised to k, and xk minus 1 by 2 raised to k minus 1 and xk minus 2 by 2 raised to k minus 2. Now compare. This is a xk and x2 raised to k. Which is bigger?
2 raised to
2 raised to k.
Very good. 2
2
raised
raised
to
to
k.
k.
If you compare xk minus
Screen
1
is
with
not
2 raised to
visible, sir.
it may happen due to
Where
in
your screen disappeared.
Screen is visible, sir.
see it might be
Uh,
happening. Is it
Screen
clear
is
now?
not. Yes.
Yes, sir.
Yes, sir.
See,
yes.
Yes, sir.
okay, so it happens due to internet connectivity. So please don't get panic. It for few moments it may get disturbed, but again you can see it clearly. So don't worry about it. Anyway, xk minus 1 is less than 2 raised to k minus 1. Xk minus 2 is less than 2 raised to k minus 2. Why it is true? Because our induction hypothesis. Yeah, up to
Yes.
k, this is true. That means xk is less than 2 raised to k, xk minus 1 is less than 2 raised to k minus 1. Up to k, this is true, and then this therefore this is true in this case. So this is less than. It is clearly less than, right? Okay, fine. So
सर स्टुडंटला म्यूट करायला लावा ना मागचा आवाज फार येतोय
keep your mic off. Other people should keep your mic off, right? So now x2 raised to k, I can write it as 2 raised to k minus 2 plus 2. They just add and subtract. So it is same as 2 raised to k minus 2 into 2 raised to 2. This is the very simple calculations. So 2 raised to k minus 1 is 2 raised to k minus 2 plus 1. Right. So it is 2 raised to k minus 2 into 2. So this is easy to observe. Right. So now we are here now. 2 raised to k plus 2 raised to k minus 1 plus 2 raised to k minus 1. But which is same as 2 raised to k minus 2 into 2 raised to 2, because I am splitting 2 raised to k in this way, because the value is not going to change. The value is not going to change in any way. So 2 raised to k minus 2 into 2 and 2 raised to k minus 2 as it is. Fine. Now what is the common among all these three terms? So 2 raised to k minus 2.
K minus 2.
Right. So 2 square plus 2 plus 1, which is 2 raised to k minus 2 times 7, because this bracket is 7. So 4 plus 2 plus 1. Right. Now, okay. So what we have now? 7 here. Now observe one more thing. Observe that, note that 7 is less than 8, and what is 8? Is 2 raised to 3. Am I right?
Yes, sir.
So very good.
येस
Therefore, we started with xk plus 1 and we reached to this step 2 raised to k minus 2 into 7. We reached to this step, but 2 raised to k minus 2 as it is, and I am going to replace 7 by 2 raised to 3, and this as it is 2 raised to k minus 2. So keep your mic off. 2 raised to k minus 2, 2 raised to k minus 2, 7, and 2 raised to 3 is 8. So first factor is same, no doubt, but second factor is a greater in second expression. So this expression is bigger. Fine. So, but what is this? The bases are
2
equal.
raised to k plus 1
2 raised to k minus
K
2
plus
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 3.
1.
So that is 2 raised to k plus
Is
1.
to k plus 1.
Very good. So this is what we wanted to achieve. Xk
Yes.
plus 1 is less than 2 raised to k plus 1. Ultimately, we reached to our goal. Therefore, xk plus 1 less than 2 raised to k plus 1. Hence, the statement is true. Is true for n is equal to k plus 1. Therefore, by induction, the statement is true for each natural number. For each natural number. Fine. That is xn is less than 2 raised to n for all natural numbers. That is what we wanted to prove. Now we can believe that this is true for all natural numbers because of induction. Right. So in this way, we are able to prove this because we need a strong induction. And how strong induction helpful? Because immediately, since we are assuming up to k, the result is true. Immediately we can apply this to this xk minus 1, xk minus 2 immediately, and then the rest of the calculations becomes easy. Right. So I will give you one more problem for you that you can work out using strong induction, and then you can understand. And during our practical session, so we'll be conducting practical sessions online. I will provide you some question set, and then we'll discuss many problems during practical sessions on induction, right? So in theory lectures, we will be focusing on theory part, right? Because we have to cover lots of theory. So for n belongs to n, define an as follows. Now similarly, like xn's, we want to define an. So my a1 is equal to 1, a2 is equal to 8, and an is equal to an minus 1 plus 2 times an minus 2 for n greater equal 3. So a1 is 1, a2 is 8, and now using this expression, or this is called as a recurrence relation. So this expression you can calculate x3, x4, x5, and so on. You can calculate all ans. Okay, so prove that. Prove that for each natural number n, an is equal to 3 times 2 raised to n minus 1 plus 2 times minus 1 raised to n. Now, problem is very easy to understand, right? No, not difficult at all. So you can understand it easily. So therefore, I will leave it as homework. You just think over it and then try to understand it, because I have explained all the details. Unless you try on your own, this will not going to help you, right? So try to apply whatever we discussed so far, and then try to understand the techniques, right? So and we'll discuss more about more problems during our practical sessions. Fine. And during some sessions also we'll try to prove. So what is our question? What we want to prove is, we will discuss during this practical session. So what we want, we will prove that
Sir, I have doubt. I
yes,
have doubt to calculating xn.
which xn?
In previous problem, we defined the xn.
Huh?
That x5u, we calculate x5u as a x4 plus x3 plus x2.
Huh?
We not add the x1. Why we didn't add the x1?
What is xn? Xn is sum of previous three terms. Xn is, go one step back, n minus 1, plus go 2 step back, xn minus 2, go 3 steps back, up to 3 only, right?
Achha. Yes.
Now you tell me what is x100. Is x99 plus
Plus
x98
x98 plus
97.
x97.
That's it.
Yes.
Only three terms. right? And therefore you can
Yes,
calculate.
yes.
Fine.
Thank you, sir.
So we'll try to prove during practical session that uh, weak form of induction strong form of induction, and well ordering property are all equivalent. So this will prove at some point of time. So right now we'll not bother about it, right? So these are equivalent, but for that you need to understand some set theory, right? Some logic behind set theory, then you can understand it in detail. Okay, fine. So let us go to the next part of our topic. So all of you know the definition, what is a set. So what is a set? Right, so all of you know the definition of set is a collection of objects.
Similar objects, collection of similar
It is
objects.
a collection of meaningful objects. Meaningful objects, or sometimes it is also said that it is a collection of well-defined objects. Well-defined objects. So the meaningful means what? Suppose you say that I have books, then it doesn't make sense. I have books, I have collection of books. Which books? Unless you define the name of each and every book, the collection is meaningless, right? So the only saying I have collection of books, that you cannot, that doesn't make any sense. So whatever you are saying, it is a collection, it is meaningful. The objects are meaningful. You can say that I have set of all students in the college, and therefore if you collect all the students in the college, then every student has a name, and therefore every object. So if I look at the set of all students from A division, right? So is it meaningful? What are the objects in the set? Objects in the set are students, and
Student.
each student has unique identity. Each student has unique identity. It is not going to happen that today some XYZ student, tomorrow it is not the same student. Today it is some student. Suppose the student of name of some student is Sham, then tomorrow also is a Sham. Not going to change your face, his face, not going to change his name. So the meaningful, not going to change, unique identity, right? So you can say the collection of all fruits, but if you define particularly what fruits, 5 apples and 3 mangoes and so on. So each and every object makes sense, right? So uh, now, and you know the various properties of set. Right, so we'll just try to understand very elementary properties, and some properties we'll discuss as when we need it. Whenever we need the particular property, we'll discuss at that time. So suppose X is a set, right? A subset of X, then uh, then A is said to be a subset of X if, so A is said to be subset of X. What does it mean mathematically? How will you write down?
subset X.
Mathematically, A is a subset of X means every member of A is also member of X.
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 Okay. So every member of A is also a member of X, right? That is, for every X in A, X is also member of A in symbolic notation or in short. And all of you understand the meaning of this. For each there exists, right? So there should not be confusion about this notation. I think I have already told you about these notations, right? So if you choose any member, you just close your eyes and choose any member of A and go open your eyes, you will find that that element is a member of set X. If it happens to be true for all members, then completely entire set is lies inside X, right? So we write it as A is subset of X. So this is a notation for subset, right? So now all of you know what is union. Suppose A, B are subsets of X, then what is A union B? Then what is A union B? So A union B is a collection of all those objects such that X is in A or X is in B. Right? The collection of all those objects from universal set X. Universal set is X. And what is union? The collection of all objects which are either in A or in B. Right. So that you can clearly understand. No need to have detailed explanation. So if A, B are subsets of X, then what is A intersection B? It is the collection of those objects from our set X such that X is in
Which belongs to A.
and X is in B. Fine. Okay, so let A, B are subsets of X, then A minus B, or it is also denoted by A backslash B. So A minus B or A backslash B is a set. Let me first of all explain it geometrically. If this is my set A, this is my set B, that means the A backslash B or A minus B is those elements which are in A, but those elements are not in B. That means, so for example, if you look at this element, this particular element alpha, what is the property of alpha? Alpha is in A and alpha is in B, right? So but we don't want such elements, we want to remove such elements. The elements which are in B, the members of A, those are in B, right? So therefore what is this? The X, those elements in A which are not in B, right? That means the elements which are overlapping with elements in B that are overlapping with B, remove such elements, right? And therefore from this Venn diagram, so the definition of A minus B is clear. The elements in A which are not a member of not members of B. Then what is A minus B? So A minus B is A, that means remove the part of B from A. What is the meaning of A minus B? Remove part of B. So this is a part of B, overlapping part of B. So this is overlapping with A. So remove overlapping part of B with A. So that is A minus B, and therefore what is A minus B? So from this figure, can you understand? Can I write it in some another words? different way, this A minus B.
A intersection B complement.
Very good. So A intersection with B complement, because whatever is outside B, that is B complement, that's its intersection with A. Very good. So that is what the intersection of sets. Similarly, what is B minus A? B minus A is this part. So remove part of A from B. So symmetric difference of A and B is denoted by A delta B. And what is the symmetric difference is, so symmetric difference of two sets is A delta B is A minus B union with B minus A. So this is A minus B and this is B minus A, right? So therefore just remove, and therefore what should be the alternative way to write down A delta B symmetric difference? As
Intersection B.
Pardon?
A union B minus A intersection B.
A union B, very good, minus
minus A intersection B.
right. So from union remove the overlapping part, intersection part, right? Or you can have alternative definitions also. The like A minus B is A intersection B complement. So similarly A minus B is A intersection B complement union with B intersection A complement. So these are the different ways to see the symmetric difference of two sets. Fine. Suppose please keep your mic off, family of sets. Now all other properties you can understand. All other properties means what? What is union of three sets? So union of three sets is same as just take union of two sets and take union of that with third set and so on. So all other properties you have. So A intersection B union C and so on. All properties you can understand easily. So family of sets. So let A1, A2, AN are sets. Then we write then okay, so B, suppose A1, A2, A and B sets, then A1 union A2 union AN, we write it as union of A k's A running from 1 to n. This is a shorter way to write down the union of n sets. Similarly, A1 intersection AN, intersection of these k sets is intersection of AK, k is from 1 to n, right? So this is a shorter way. But in this collection, this is a collection of n sets and we want to take union of this collection. Sometimes you may have infinite collection, right? So consider an infinite collection of sets A1, A2 and so on. How many sets I am having? I am having infinitely many sets, right? So A1, A2, A3, A4, I have infinite collection. So this is called as infinite collection of sets. So then I will write union of, so I will write A1 union A2 and so on. So union of this infinite collection as union of AK, k running from 1 to infinity. Right, so this is a shorter way we write the, but here or, so this collection we can write as AK, k belongs to n. right? So this is a collection. So what is the meaning of this? This is a set of sets, right? So what is it? What does it mean? It is a set of sets. So set of sets means what? It is a collection of sets. So and what is a collection? AK. K belongs to N. That means so this collection includes set A1 because the K running K belongs to natural number. So one is there, A1 is there, A2 is there, A3. So this is a set of all sets. So for example, suppose A1 is a set of students. So my universal set is students in the college, all students in the college. In the college, right? All the students. What is A1? A1 is a set of all students from FYBSC A division. Right. So what is my set A2? The set of all students from FYBSC B division. Right. A3 is a set of all students from FYBSC C division. A4 is a set of all students from FYBSC D division. Right. A4, A5 set of all students from E division, and we have 6 divisions. So F division, A6. A6 is set of students from F division. Right. And if you take union of AK, K is from 1 to 6. Right. So what is this set? My set is A, not A. So suppose my set is some P. What is P now? P is the set of,
FYBS.
right, all the students from FYBS.
FYBS.
Right, because we have collected all the divisions. So this is a collection of all students. And therefore, what is A1? A1 itself is a set, right? And I can write this as collection A1, A2, A3, A4, A5, A6, right? So if I denote this by some script C, then this is a collection of sets. So it is a set of sets, right? Set of sets. Set of sets. And then in day-to-day life, you are dealing with many such sets, right? Always you are dealing with such sets where you deal with such sets, set of sets. And you just think about it later on where you come across such kind of situations. You deal with set of sets. Fine. Okay. So we are now want to discuss next property of set, that is power set of a set. So let A be a set. Right. So when I say set, then I mean to say that it is a general set. Whatever set in the universe available, it could be set of all stars. It could be set of all planets. It could be set of all people in the India. It could be set of all countries and whatever. So whatever I am doing is for general situation, and in any particular case you can apply that theory. Right. So let A be a set. Then power set. Uh, Power set of A is the collection of all subsets of A. Collection of all of A. So power set is a collection, that is power set of A is the set of all subsets of A. Set of all subsets. So that means it is a set of sets. But what are the objects in this set? Objects in the sets are sets. When we say set of all students in A division, then what are the objects? Individual student. Right. So individual student is object. But when we say the set of all divisions, right? Set of all division, that means what is the object? One division is object.
One
And
division.
right, one
One
division is
division.
and the object itself is a set in that case. So now you can understand the difference between the set of sets and our right, and therefore the objects in the set is an abstract concept, is a general concept, not necessary that it is a very single undividable objects. It can be a collection, right? That is some general sense you have to think about. So power set of set A is denoted by the special symbol PA, right? So power set of set is denoted by the script C, not our usual script P, not our usual P, right? Because we want to make difference. It is a very special symbol for power set because power set has some special properties, right? So for example, A is equal to A is equal to some single element set. Then can you write down power set of this set?
Phi and A.
Very good. Phi and set A, because if I write this as phi and A, then this is not correct because A is not a set. I want subsets of A and A is not a subset. So again, let me clear that A is subset of A and A is subset of A. So this is not correct. This is correct, right? But A is a member of A. This is correct. A is a member of A is correct, but A is the element A is subset of A is not correct. But set A is a subset of A is correct. So do you understand the difference?
Yes, sir.
And
Yes, sir.
so empty set is always a subset of every set.
Every
So empty set is always a subset of every set, no doubt. And therefore, when we talk about collection of subsets of set, the empty set must be there. Right, fine. Now let us go to the next example. Suppose A has two elements, A and B. Then write down power set of A.
I, A and B.
Uh, A. Okay, phi singleton A,
Phi,
singleton,
set A and set B.
and both,
A comma B, both.
AI, comma B.
right? So this is a subset of A, this is a subset of A, this is a subset of A, this is, and every set is a subset of itself. Note this, note that every set is subset of itself, right? That means I can always say that A is a subset of A, because by definition of subset, every member of A is also member of A. So by definition, it is clear that every set is subset of itself. Fine, and therefore the elements in power set are this. Okay, fine. So let us think about, suppose, please keep your mic off. If you are not talking with me, keep your mic off. Suppose A is equal to 5, empty set. Now what are the subsets of empty set? Then what is a power set of empty set? It is a collection of subsets, right? Basically it is a collection. So I should write down it in set notation. So it is a collection, but what are the members? What are the subsets of empty set?
Phi only.
Right,
Phi.
right. So and therefore what we can say, power set of empty set is non-empty. Am I right?
Yes.
Right. So because in power set of phi there is a member phi. Right. So in power set of empty set there is a one member which is empty set, and therefore power set of empty set is non-empty. So try to understand this statement. Why? Think about it. This is a logical statement. Okay. Now let B is equal to power set of empty set. Then what is power set of B? You think about it. The question is clear. Question is B is power set of empty set, and you know what is the power set of empty set as a one element, singleton element. Then what is the power set of B? So now you can understand. The first example, very first example, if you have single element set, what is its power set? Right? Now, what is a B? B is a power set of empty set. So, B is a single element set. Then what is its power set? So, you should think about it. You need some logical understanding in this case. So, if you are not able to understand, I will tell you next time. But you try to understand this. Not difficult at all. Fine.
Set of B will be phi and set phi, right?
Yeah. So, you think about it. Write down later on. I should not tell you everything, because if you want to improve your ability, you need to use, you should face the difficulties. Otherwise, your ability, your power will not be improved. Right? So think about it. So let A is equal to A, B, C, then find power set of A. Now similarly, you write down all these things. Now the question which I would like to ask you is, okay, let me define something, then I will ask that question. The cardinality of set is the number of elements of, please keep your mic off, in cardinality of set A is the number of elements in set A. Right, the cardinality means number of elements in the set. For example, if A is equal to singleton element, then what is cardinality?
1.
Right,
One.
cardinality of A is 1. If A has 2 elements, then cardinality of,
2. 2.
very good, cardinality of A is 2. If A is empty set, then what is the cardinality of A? Is 0.
0.
Very good. So the cardinality of set is denoted by a special symbol. Cardinality of set A is denoted by this notation. Right? Therefore, if A is singleton set means single element set, then the number of elements in A is 1. If cardinality of the set A has 3 elements A, B, C, then the cardinality of this set is 3. Right? So this is a notation. This is a notation for cardinality. So I think definition is very straightforward, very easy. So there should not be any confusion. The point that I want to raise is, the question I want to raise is, if cardinality of A is 1, then what is cardinality of power set of A?
2.
2.
Very
2.
2, sir.
2, right?
2.
Yes,
2.
that's right.
If cardinality of A is equal to 2, then what is cardinality of power set of A?
4.
3.
4.
4.
4,
And
sir.
4. 4.
4, sir.
if
4.
A is,
4.
A is empty set, then what is the cardinality of power set of empty set?
1.
1.
1.
Very good. So now can we generalize this? What is the generalization? What is the
Cardinality of power set is 2 raised to n.
very good? If cardinality of A is n, then what is cardinality of power set of A? That is something general situation. Right. So and therefore what is our proposition? Proposition means it is like a theorem but not exactly same as theorem. So proposition is a statement which we may not be using in any theorem, or we may use somewhere, but it is very basic statement and we can prove it, or its proof is known. So there are various kinds of words in mathematics you will learn. So proposition, theorem, lemma, then corollary, then conjecture. Conjecture. So what is a proposition? Proposition is a statement whose proof is known, but not a very big theorem or big statement, big result. Theorem is a big statement or big result whose proof is known. What is a lemma? Lemma is a statement or result which is not very stronger like theorem, but we can use lemma in the proof of some theorem. This is a small theorem, small result which we use in the proofs of some big theorems, right? And corollary is a result or a statement which is very immediate from theorem. If you know some theorem, from that theorem immediately we can get the proof of small result, that is a corollary. And what is a conjecture? Conjecture is a result or statement. It is not theorem because its proof is not known. Proof not known. Not known. Conjecture is a statement. So the statement which we may not, the proof not known, but people believe that it is supposed to be true because nobody have proved that it is false. That means there is no evidence that some statement or some result is not true, or there is no evidence which proves that it is false, and therefore people believe that it is a true unless it is proved that it is not true. So such statement is called as a conjecture. And there are many conjectures in mathematics. People made those conjectures, and there are millions dollar prizes to prove that either it is true or it is false, right? And if you learn higher mathematics, you will try to understand such conjectures, right? One of the conjecture is generalized Riemann hypothesis. This is the one conjecture, or there are many such conjectures that you can have, and there are prizes for proving such conjectures. Anyway, so now the proposition is, if cardinality of A is n, then the cardinality of power set of A is 2 raised to n. Right, and next time we will try to prove this proposition. Right, this is true for all natural numbers. Right, so if you want to prove something for all natural numbers, certainly you can use induction, and then you can prove it is true for all natural numbers. Fine. So any doubt, any difficulty?
No,
far?
sir.
Very good. So now
No, sir.
you can see this the write-up on your Google Teams. You just see log into your Google not Google Teams, Microsoft Teams, and then you can find notebook in Microsoft Teams. In that notebook, you will find this notebook for our. See, you can you see my screen now? My team screen. In this notebook, class notebook section, you can find this notebook, and you can see the whatever discussion of today's lecture you can see, and every day every time I can write in this notebook, and you can see it, right? If you not do not have in mobile, I think you need to download a notebook, right?
Yes,
Microsoft
yes, sir.
notebook. You download it, and then log in, and then you will be able to see this notebook,
Sir,
right?
so we have to log in it with this college email ID or the personal one.
Yeah,
So
college
what
email
will
ID.
be the
Because
code?
see,
Yes, sir.
because your ID I have added in my team, and therefore if you log in with that ID,
Okay, sir.
you can be member of my team, and you go into my team, and you can see my notebook, class notebook, right?
Okay, sir. Thank you, sir.
Fine.
Sir,
Now,
sir,
yes,
I am
Yes.
not in the team.
yeah, you are not in the team. You just send me a message, or you tell me your name, then I can add you, right?
I am Omkar Munde.
Omkar Munde. So I will note down your name.
Sir, I
Om.
also not in the team.
Okay, are you member of WhatsApp group?
Yes, sir. Yes, sir.
FY Basic Mathematics WhatsApp group?
Yes, sir.
Then I will
No,
Yes,
share.
sir.
Okay,
Yes,
either
sir.
you join the WhatsApp group, and then I will share the